Hello and welcome to Diksha Karnataka YouTube channel. So today I am going to discuss a very important chapter for all of you PU1 students. So if you are currently studying in PUC 1 and you are struggling with one of the important chapters, then definitely you should check this lecture from the starting to the end, right? Motion in a straight line. Now motion actually can happen in multiple ways. One of them is when we are considering motion in a straight line, that means it's a one-dimensional motion. In many classes they are calling it motion in 1D or motion in one dimension. What does that mean? So that means the object can move either in a straight line, either in the forward direction or in the backward direction. So there are only two possibilities. It can move forward, it can move backward, right? Now few terms that already you know, but let me discuss about them at the beginning so that you don't get confused. So there are few things. First of all, velocity. What is velocity? Velocity is basically the rate of change of its position, okay, and it is basically a vector quantity. It's a vector quantity and it is defined by displacement. Displacement over time. Now what is displacement? I will explain that. Now another quantity that we discuss in this chapter is speed. Speed is basically same as velocity, but it's a scalar quantity and it is total distance traveled by time, okay. And another few quantities we will discuss in due time about acceleration, but displacement, total distance traveled, velocity and speed, let me clear that up for you. So suppose you are I am explaining this using a motion in 2D. Okay, it can be explained in motion in 1D also. That can be slightly tricky, so I am just explaining it using motion in 2Ds initially. Suppose an object start from point A, it is going towards point B. Okay, so what is its displacement? Its displacement will be simply, if you draw a straight line between the starting point and ending point, then this is the displacement. This is the displacement. Now what is the difference between displacement and total distance traveled? But actually suppose the road is like this. Suppose this is the road. So object actually did not move along this straight line, it moved along a separate line. Let me draw it using a separate color so you don't get confused. So suppose the object traveled like this, okay. It can be any random motion, but this is the actual motion, right? So when we consider the displacement is basically the straight line distance, the shortest distance between the 2 points, okay. Whereas we consider the total distance traveled, you have to consider the entire path length of this, right? So here if you see that the distance traveled is far less, okay, the displacement is far less compared to total distance traveled. Total distance traveled is more in the same time. So speed is here is more than velocity. Velocity is far less because time taken to reach from A to B is same. So velocity is along this direction. So this is the velocity's direction. This is velocity, okay. And what is speed? So when the object is moving in this rate path, that is speed, okay. Now how it is possible in a straight line motion? So when you consider a straight line motion, okay, suppose this is the straight line motion, object is moving along this, a car is moving, it can go forward, it can come backward. So this is suppose my starting point A, this is my ending point B. So it moved forward for some time, it came back for some time, then again it moved forward for some time, like that it is going forward, backward, and then ultimately reaching its destination point B. Okay, so in that case obviously speed and velocity can be different. Now if the object is moving in a particular straight path in a particular direction, okay, without changing its direction, if the object is moving in a particular direction, then it has to be noted that the speed and velocity, the value of speed and velocity will be same. Okay, slowly we will introduce some other terms, average velocity, average speed, etc. So you will notice what is average velocity, what is average speed. But for now you have to remember that speed and velocity are two different things. Velocity is a vector quantity which has a direction involved to it. Okay, starting and ending, that is the direction of velocity. Speed does not have any particular direction, so it can be in any case. For example, another example I like to give you before I start our today's session completely. Suppose a object is moving in a circle. Object is moving in a circle. Okay, so it started from A, okay, and it ended at B. Same point, A and B are same point. So it started, it rotated once and ended at B. So a runner is running, so 200-meter race or 500-meter race. So it completed its motion at B. So what is the displacement? Displacement in this case is 0. So displacement in this case is 0. Is 0. But total distance traveled, if you know the radius of this circle, total distance travel is 2 pi r, right? So even if the displacement is 0, so velocity is 0 here. So velocity, final velocity, the total velocity or average velocity is 0, but speed is not 0. Right? So velocity can be 0, speed cannot be 0. But if speed is 0, then velocity has to be 0. So that is one few conditions. Based on that, we see some of the assertion reason based questions or statement based questions as MCQs. So be careful with these concepts. So speed may not be 0, velocity still can be 0, because velocity is basically dependent on starting point and ending point. So I hope all these concepts you have studied in your lower grades, but because it's a fresh chapter, so I just like to remind you some of the fresh concept as well. Now let us start. So what we are going to cover in today's session: introduction to basic ideas, motion, rectilinear motion, point objects, and kinematics. Next we will discuss instantaneous velocity and speed. So instantaneous, what is the instantaneous meaning? Okay, from average to instantaneous, limits, tangents, etc. Next we will also learn about acceleration, average, instantaneous acceleration, xt, vt graph. Lot of graphs will be there, lot of derivations will be there using graphs as well. Kinematic equations, 3 equations of motion, graphical derivations as well. Then we will discuss about applications, free fall, Galileo's numbers, okay, stopping distance, etc. And lastly we will look into the summary and some questions. Okay, so this is the session today. So let's start with introduction. So motion is common to everything in the universe. Let's learn and describe precisely. So we will see why I am saying that motion is universal. Okay, so now what is motion? Motion is change in position of an object with time. So if the position is changing with time, then we call it motion. Okay, we walk, we run, we ride bicycle. Motion is in daily life. Okay, even while sleeping, air moves and in and out of our lungs, so we breathe. If we stop breathing, we will die. So definitely we are breathing whenever we are sleeping also. That means that also some motion is involved there. Okay, blood flows, blood is always flowing in your veins and arteries, so that is also a example of motion. Leaves fall from the trees, water flows down the dam, earth rotates around the sun every 24 hours and revolves around the sun once in a year. Sun itself moves within the Milky Way, which moves within its local group of galaxies. So it is a complete motion. Okay, we cannot say anything about absolute rest. So there was one concept, absolute rest. We do not have this concept of absolute rest. No matter, even if I am standing here, I am not moving, still the earth moves, so I am standing on earth, so I am moving along with earth, right? So I am always moving, no matter, even if I am sleeping, I am moving because of the earth's motion. Okay, my position with respect to universe changed slightly, right? So basically that means whenever we are somewhere, we are always in motion. Motion is the most common thing, rest is exception. Okay, now central question, how does the position of an object change with time? This chapter builds tools to answer it. Okay, this chapter develops the concepts of velocity and acceleration restricted to motion along a straight line. As I mentioned, what is a straight line motion? When the object moves in a fixed line, if it is moving forward or backward, that's it. We are not going to do into some difficult questions that we will answer in the next chapter. End goal, simple kinematic equations, uniform accelerations, idea of relative velocity. These are the main goal, main ideas of this chapter, right? Now let's move on with first point is rectilinear motion. So rectilinear motion or linear motion, so basically it means motion in a straight line. Okay, motion of object along a straight line is called rectilinear motion. Okay, rectilinear means only one line. Okay, there can be multiple lines. To avoid multiple lines, we are saying only one line is there, and through that line every object is moving. So it's like a highway. The highway roads are very, very straight. There is no curve or nothing like that. So that is a rectilinear motion. Okay, the entire chapter is confined to this case. For uniform acceleration, a set of simple equations can be obtained as well. Okay, point object approximation. What is point object? So whenever we see object, we see object, we say object, but what is the meaning of object? Object is basically a point object. Now if I say a point object, what does that mean? Point object is, this is point object, simple dot on the screen. But is our objects day-to-day life that we observe, be it a bicycle, be it a car, be it a bike, be it anything else, be it ourselves also when we walk, are we point object? Obviously not, we are not point objects. Then how can we apply the formulas, equations, etc. that we learn in this chapter in our real life, right? Same thing can be applicable to our real life as well. Now there are two ways to do it. First of all, you will learn a little bit more about that in our center of mass chapter. So first of all, we consider the entire mass is located at a single point, and then we proceed. So that is one way. Another way is that we approximate, is that approximation that we do is if the distance of motion is very long compared to our size, okay, then we say this is a point object. Okay, objects in motion are treated as point object, valid when object size is far less compared to the distance moved in a reasonable time. For example, every day I come to my office by traveling in a vehicle for 25 kilometers. Okay, in Bangalore 25 kilometers is a huge distance. My vehicle length is say 2 meters, right? So 2 meters compared to 25 kilometers is a huge distance. So my vehicle can be considered to be a point object, right? So it does not matter how big it is, how small it is, the distance that I travel is 25 kilometer compared to 25 kilometer, a 2 meter vehicle can be considered as a point object. So that is major important thing that you have to understand, that whenever we say that point object refers to the distance with which it is being compared. Okay, if the distance is large compared to the size of the object, we still approximate that object to be a point object. Okay, works without much error. I think 99.9% of the time this works perfectly, right? And in many real life situations as well. So this, the formulas, the equations that we are going to use is always valid for even non-point objects as long as the distance traveled is larger. Okay, and there are one more way that I mentioned. You will learn about it in our rotational motion chapter. Okay, in later throughout the session. Now kinematics. What is kinematics? Study of ways to describe motion. Does not go into the cause of motion. Cause of motion means a car is moving. Why the car is moving? Okay, because there is an engine which is burning fuel, which is applying a force on the wheels, and that wheel is rotating, and that's why the car is moving. So we are not interested on those all processes in this chapter. Okay, we are only interested that car is moving or not. Car is static, car is moving. That's it. Okay, why the car is moving? For example, Earth is moving around the sun. Why? Because sun is attracting it with towards its center by gravitational force, and etc etc. There are complicated things are there. But yes, we are not interested in all those concepts in this chapter. We are only interested that earth is moving, car is moving, I am moving, or you are moving. That's it. We are not interested why it is moving. We will learn about causes of motion in our fourth chapter, where laws of motion are there. So there we will study about causes of motion. So motion, first we will start with motion, because it is in our observable universe, whatever we can see, everything is moving. So motion comes first. Later on we will inquire why it is moving. So why it is moving is not part of this chapter. It is a part of a future chapter. Okay, next, instantaneous velocity and speed. Now let us understand what is the meaning of instantaneous. So as you know, as the name suggests, instant noodle. Okay, instant. Okay, I need that in instant. Instant means exactly at some times. Small amount of time is basically called instant, and exactly at certain amount of time is also called an instant. So for example, at this current instant, 1 p.m. So 1 p.m. is the instant, exact time. 1 p.m. means not 1.01 or not 12.59. It is exactly 1 p.m. right? So that is an instant. So how fast an object moving at a single instant of time, that is called instantaneous motion. Instantaneous velocity and instantaneous speed, both we are interested in. So not only motion, but also we need to find how fast it is moving, right? So instantaneous velocity, instantaneous speed, both we are interested in. Okay, as I mentioned, instantaneous means exactly at certain time. Okay, exactly at instant. Now why instantaneous velocity? But before going into that, let us see what is average velocity. Okay, we generally, the velocity that we measure, okay, are basically average velocity, average speed. What is the meaning of average velocity? Okay, average velocity, the concept that I discussed at the beginning of the chapter, whatever we have said, that is actually average velocity. So average velocity is basically given by like this. Okay, now velocity, speed both have same symbols. That is one confusing thing. So let me write it as velocity. This is not vector sign, by the way. This represents the average. This represents average. If you put an arrow to it, then it represents vector. Without arrow, it's just an average value. Average velocity is displacement by time. Okay, so what is the total displacement divided by time is average velocity, and average speed is total distance traveled by total time. Okay, so this is the average speed and average velocity. As I mentioned, average velocity can be 0, average speed may not be 0. Generally average speed is not 0. If speed is 0, velocity will always be 0. But yes, they represent average value. Average value means over a certain amount of time. The car can, in between that time, suppose a car is moving on a racing track. Car can slow down, car can accelerate, car can move very fast, car can slow down almost absolutely to 0. So we are not considering that factor. We are only considering starting point, ending point, what is the total distance traveled, or starting point, ending point, what is the displacement. And based on that we are calculating average speed and average velocity, right? Clear? So average speed and average velocity does not tell me the information that exactly say at 5 minutes after it started what was its speed or what was its velocity. That information we will not get it from this. We assume that as if the entire duration the object has moved with that same exact constant speed, okay, which is somewhat beneficial for us, because it will give us an idea that throughout the journey what was the average speed or average velocity, but it will not give us that, okay, the car was also moving at, for example, you are traveling on a highway, the road speed limit is say 80 km per hour. You are traveling in that highway 80 km per hour, but sometime you moved into 120 km, sometime you moved into 60 km. Your average speed was 80 km per hour, and you are not giving any traffic challans. But when the speed cameras are checking your motion, they found out that, okay, at this particular time the car was moving at 120 km. So when they come to you and saying that, okay, you have broken the law, you say, no, look at my meter, I am traveling average 80 km only. So right, understood. So at certain point you have broken the law, okay, that means you are subject to traffic challan, but obviously you have to have proof. So instantaneous velocity will tell you that, okay, that at this instant your speed was way above the limit of the road, right? So basically that is the way of checking motion more appropriately. So motion average velocity gives you the overall average, not exactly at a particular moment what was your velocity or what was your speed. That is super important. Okay, so limitations of average velocity tells how fast an object moved over a whole time interval, does not tell how fast it moves at a different instant within that interval. Okay, so what is the fix for that? Define, so we have to have instantaneous velocity v at instant t, defined as the limit of average velocity as delta t becomes infinitesimally small. Infinitesimally small means very, very small time, almost zero. Okay, so in calculus language, the differential coefficient of x with respect to t, okay, this is in terms of differentiation. We will briefly talk about differential method, but not in detail. Obviously your differentiation is weak, but yes, we need to learn a little bit of differentiation. We will see that. Okay, it is the rate of change of position with respect to the time at that instant. Okay, so how to do that? So so if you are talking about in terms of limit, okay, this is how it is written. So instantaneous velocity v is given by limit delta t tends to 0, change in position divided by change in time. So in the small time interval delta t, what is the change in its position, and as you take the time t close to 0, what will be this ratio? This ratio will neither be infinity nor be 0. This will be having a fixed constant value. That is very, very important point to remember. Okay, so even if you take the time closer to 0, that is the beauty of calculus. So you will learn in our calculus chapter when mathematics is being done from that chapter. Do pay attention on calculus whenever it comes to your syllabus. I think in first PUC, last 1 or 2 chapters are based on calculus. So you will start learning differentiation. Integration you will learn in your second PUC. So that's why one reason most of you struggle with physics, because physics involves certain limit of calculus. Okay, so that is one very important point. I will try to address as much as possible in this, but remember that when you are writing this limit delta t tends to 0 delta x by delta t, it does not give you an infinite value, or it does not give you a 0 value. So if I write say 5 by 0, it is infinity, right? 5 by 0, it's infinity. 0 by 0, undefined. 0 by 0 is actually undefined. It is not infinity, not 0. Okay, it is not, it is called undefined. But in calculus, okay, there is a way we can calculate that value. For example, sine x by x. Sine x by x. So if you put x equals to 0, what you will get if you put x equals to 0? Sine 0 by 0, right? Sine 0's value is 0, so 0 by 0 is undefined. But if you take limit x tends to 0, it becomes 1. Okay, so that is the beauty of calculus. So you will learn it with time. Okay, you will learn it with time why it is not 0, not infinity, but it is actually a finite value 1. So there are few tricks are involved, but you will learn it later on. Anyway, And in terms of differentiation, this actually can be written in a differential form, which is dx by dt. Dx by dt actually is the shorter writing of the same thing. If you are writing it like this, you can write it like this. So this is the representation of the same thing. Okay, instead of writing limit delta t tends to 0, etc., we directly write dx by dt. Dx is differential. It's a very small change in x. When the time changes, also very, very small. That ratio dx by dt is called the instantaneous velocity. Okay, so first of all, graphical method, we will use graphical method, or numerically method is slightly longer. Okay, so let us see. So graphical method, what is graphical method? So you have a graph. You have a graph given over here, and you want to find the instantaneous velocity at certain instant. Okay, when you plot the average velocity looks like this dotted graph. Okay, dotted graph looks like average velocity. So consider motion of a car with the equation is given over here, x equals to 0.8 t cube. Okay, take delta t equals to 2 seconds, centered at t is equal to 4 seconds. So we are trying to find average velocity at t is equal to 2 seconds. Okay, now obviously decrease the time to delta t to 1 second. Okay, chord becomes q1, q2. So if you take a small triangle, basically you need to draw a small triangle over here. Okay, this axis represents delta t axis, this axis represents delta v axis. Okay, here delta x axis. Okay, so this is the displacement position time graph. So this is the position time graph. So you have to construct a small triangle around the point where you are trying to find your instantaneous speed. Based on the point where you are trying to find, obviously the triangle will be different. Okay, and this is actually tangent. This line is a tangent line. This is a tangent line, and if you draw this tangent, based on this you have to find the average velocity. So how to do that? So there is a rule, you will learn it in the straight line chapter. Okay, there is something called slope of a graph. Slope of a graph. Okay, what is the slope of the graph? Slope, if you remember, when you are when we are kids, okay, we used to go into the slip and we used to go down the slope. So that is called slope, right? So you climb up and you go down the slope. Slope means how steep something is. How steep something is, that is called slope. Okay, now slope basically represents how fast the object was moving at that point of time, and that slope is basically given by, always remember, delta of the y-axis. Delta of the y-axis divided by delta of the x-axis. Now here y-axis is represented by x. Okay, so here it will be delta x by delta t. Okay, y-axis is represented by time axis, so it will be delta t. So delta y by delta x is called slope of the graph. It is, you will learn it in the straight line chapter. Okay, and that can be calculated using a simple thing, that is tan theta. If you can calculate this triangle, if you can measure this angle theta, then tan of this angle will give you this slope. Okay, so basically you need to have a scale, draw a tangent, then measure delta y, delta x, and then find their ratio. That will give you the slope. Alternatively, you can measure the angle as well, and from the angle you can find the tan theta. Now even if you change the distance delta x to small, okay, you will always get the same value. This slope will not change. Slope for a given point will not change no matter how small your distance is or how large your distance is. Okay, so at limit delta t tends to 0, the chord becomes the tangent at the x curve p, velocity at 4 seconds, slope of the tangent at that point. So velocity at t equals to 4 is the slope of this graph at this particular point. So using this slope you can calculate the instantaneous velocity. So this method is only used for instantaneous velocity. There was one question in KCET, a graph was given. Okay, a graph was given like that, and it was asked which point the object has moving fastest. Okay, so this was the graph was given. So there was some point given A, B, C and D. Okay, So these are the points given, and they are asking that which point the object was moving fastest. So how to find that? So that is basically the exact same concept that you are learning now. You need to apply there. So basically you need to calculate different slopes. So here if you see that the velocity was 0, position was 0, so object speed was 0, average velocity, average speed, whatever you call, or sorry, instantaneous velocity, instantaneous speed, whatever you call, is 0. What about B? If you have to draw a tangent here, just let me erase this. Okay, you have to draw a tangent over here. So this is my point B. This is my point B. Okay, and if you see, this is delta, this is my position x, this is my time t, so delta x by delta t. If you take the same time interval here as well, okay, you will see this is delta t, this is delta x, and here as well, delta t, delta x. So which graph you think is longer delta x compared to delta t? So if you see that this one has a very large delta x compared to the same delta t, if you keep the delta t is same, delta x is much larger at C. So that means velocity at C, which is delta x by delta t at point C, is bigger than all other points, right? So from the graph, the steepness of the graph is much more at point C. Steepness of the graph is much more at point C. That's why we can say that the instantaneous velocity is much more at point C compared to any other point. Okay, so answer for this question was point C, obviously. But careful, these kind of questions have came in the past, and if you are not super confident, just draw the tangent using your pen, okay, because obviously it's a pen and paper. You may not be able to identify in some cases. If it is not super obvious, draw small tangents to figure it out, okay. Otherwise you see that point where it is most rising, the value is changing more faster than any other point. So here it is changing, but it is not as fast as it is at point C. Okay, so point C is the point where the velocity or the displacement is changing more rapidly compared to the time gap. That means at point C, the instantaneous velocity will be the largest value. Slope is largest at this point. This is how we apply the concept in real application. Okay, now let's move on. Numerical method, this is just a method for your academic purpose. It is not super important, just to understand that you can do it using dividing the point into separate time intervals. Okay, so here we have taken delta t's corresponding t1, t2, delta x, delta t, and as you are decreasing the delta t's and delta, calculating the corresponding delta x, same equation was given, right? The equation of the motion was given, I think x equals to 0.008 t square, something like that is given, right? If I am not mistaken, 0.08 t cube, sorry, 0.08 t cube. So you take small values of t, okay, find cube root of that, multiply in this equation, and correspondingly you calculate delta x by delta t. And as you can see, if you see, the value started with 3.98 when your time was 2 seconds, and as you are decreasing the time interval, it is slowly getting fixed towards a small value, which is 8400. Even if you decrease the value 0.001 as well, you will always get the same value. You have to use the calculator to calculate individual intervals, and you will get this answer. Now obviously this is not going to come in your exam, but this is a method also, numerical method. If you are doing a programming in future, if you become a programmer, okay, computer programmer, then they might give you an equation and they will say that find the average velocity for this equation. So in that case, you have to write a program which will calculate the small t's, and based on the small t value, you have to calculate the average velocity. This is a programming basically. It's a kind of programming. Okay, when I was a student, I used to write this kind of program for my physics class actually. Yes, it was part of my physics curriculum. Now, velocity from a position function. Now let us understand a little bit about differentiation. Position x equals to bt square with a value, b value are given. Find v at t is equal to 0 second, t is equal to 2 seconds, and average velocity between t is equal to 0 and t is equal to 4 seconds. Okay, so first, what is the equation? The equation was given x equals to at square plus bt. Okay, a and b's values are given. A is x equal to a plus bt square, a plus bt square. Okay, I will briefly explain the differentiation in this part. A value is 8.5, a is 8.5 and b is 2.5. Okay, these are the values which are given to you. Now they are asking what is the average velocity at time t is equal to 2 seconds, time t is equal to 0 second and t is equal to 2 seconds. Okay, how to find anything? So for that, whenever they say that average velocity or instantaneous velocity, if they ask instantaneous velocity, and they have given you an equation, so you don't need to use the numerical method, or obviously you cannot use the graphical method here. So what you need to do, you need to find something which is called dx dt. What is this? So I will briefly teach you what is differentiation is. Only one equation you need to remember for now. Okay, everything else you will learn later on. So for initial portion, only one equation is required, which is when you are differentiating. Differentiating means basically, what is differentiation? Differentiation is limit delta t tends to 0, just a second, delta x by delta t. This is called differentiation. This is called differentiation, dx dt. Okay, this is it. Okay, now one equation that I will tell you, obviously in mathematics you will learn dy dx, so that is a separate thing, but same thing. Okay, there will be something in the top, something will be in the division. So first, top portion will be generally given as a function. This is called a function. This x equal to at plus bt square is called a function. Function means if you put some value to it, for each value of t you will get a value of x as well. That is called a function. Okay, so if you put x equals to 0, t is equal to 0, you get x equals to a. That is the meaning of a function. Anyway, so we will go into that in our mathematics class, but today I am not going to discuss mathematics. The basic differentiation. What is basic differentiation? When you are differentiating a quantity. Okay, so first suppose we have ddt of, so this is the way to write ddt of, so function that we are writing, that is given by, say, a constant b, or constant k, x to the power n. This is the only thing that you need to learn. Okay, another one is there, small, that is easy, but this is the only thing that you need to learn. Okay, so what is this? First of all, this is a constant. So whenever you are doing a differentiation, the constant comes out of the differentiator. So constant will be coming out of the differentiation as a simple multiplier, right? So it has nothing to do, it will just come out. Okay, next we are differentiating x to the power n. So that is important, x to the power n. When you differentiate, the x to the power n becomes to the power n to the x to the power n minus 1. Okay, and this n comes in as a multiplier, x to the power n minus 1. Okay, so this n comes down, one n comes out, and because we have taken out one n, the power will be minus 1. This is the most common differentiation that you are going to use in your physics classes. There are sin theta, cos theta, e to the power x, etc. are there, but for now you don't need to remember them. You only need to remember this. Okay, you will learn in mathematics class. Then there might be some complicated questions where sin theta, cos theta might come in physics as well, but for now only this is important. And another one I told you. So if you are doing ddt of a constant, okay, ddt of, say, constant c, any constant, 4, 5, 6, 7, 8, 9, 10, 11, if you are doing ddt of constant, that is given to 0. So when I was a student, one of our teacher, instead of giving zeros, mathematics teacher, he used to give us ddt of c. Okay, he used to say ddt of c. Ddt of c means ddx of c, basically. Ddx of c means constant. Okay, so that means you got 0 marks. Okay, so instead of giving you 0, he used to give ddt of c. So constant, whenever you are differentiating a constant, you are going to get a 0. So for example, I am differentiating this. What is this? First we have, so obviously we will write velocity equals to dv dx or dx dt, sorry, dx dt, and that will be d dt of a plus bt square. Now obviously a is a constant, so whenever you are doing this addition, same as multiplier, you can do it d dx of a plus sorry, not d dx, I am writing mathematics, sorry, d dt of a plus d dt of bt square. So just like multiplication, you can do the normal multiplication, and obviously this one is a constant term, so that means this will become 0, and this one is in the form of kx to the power n. So here k, instead of k we have b, so b is coming out of the differentiation as it is, no change. Now t square is our variable, so it has to be same, t, the variable needs to be same. Now because the variable is same, now what we have to do, you have to differentiate. So power 2 will come out, power 2 will come out, and because we have taken 2 out, it will be reduced by 1 in the power, right? So n coming out and power becoming n to the power minus 1. That is the basic differentiation, right? So it will be 2b into t, 2bt. So this is the instantaneous velocity. Okay, so instantaneous velocity is coming out to be 2bt. Now they are asking you what is the instantaneous velocity at t equals to 0. At t equals to 0, instantaneous velocity is 0. Right? What about t is equal to 2 seconds? At t is equal to 2 seconds, v will be 2 into b into 2. Now if you see b, what is the value of b? B's value is 2.5. So 2 into 2.5 into 2, that is 10. So this is the value of velocity at t is equal to 2 seconds. Now how to calculate average velocity? Average velocity between, so the question was average velocity between t is equal to 2 second to t is equal to 4 second. Okay, t is equal to 2 second to t is equal to 4 second, find the average velocity. So average velocity can be calculated using very simple method. Average velocity is easy. So average velocity, first you have to calculate, if you see here, x is given as a plus bt square. So x is a, so this is part 1 is done, this is part b, a plus bt square. Okay, so at t is equal to 2, okay, you just need to put x2, suppose x2, you just need to put, instead of t, you just replace it by the value of time. That's it, right? So it will be 8.5 plus 2.5 into 4, that is 10 plus 8.5, so 18.5. So this is the initial displacement at t is equal to 4, x4 equals to a plus b 4 square, which is 8.5 plus 2.5 into 16. So it will be 40, right? 4 fours of yes, 40 plus 8.5, so 48.5, right? So what is the net displacement? Total displacement. Total displacement so initially the object was at x2. Initially the object was at 8.2, that is 18.5, and finally the object was at 48.5, that is x4. Okay, so initially the object as at x2, it started from somewhere at x equals to 0, time t is equal to 0, it started some x0, it moved to x2 and then x4. So what is the displacement between these two interval of time? So the displacement between these two interval of time is given by x4 minus x2 and divided by time 4 minus 2, right? This is the average velocity. This is the average velocity. So that is 48.5 minus 18.5 divided by 2, that is 30 by 2, that is 15 meter per second. So if you see, the average velocity is different, instantaneous velocity is different. So instantaneous velocity at t is equal to 2 seconds was 10 meter per second. Okay, but average velocity from 2 to 4 is 15 meter per second. Right? So average velocity, instantaneous velocity are different quantities and they can have different values as well. Right? Now let's move on with instantaneous speed versus velocity. So that's what one comparison we have done, a basic comparison in instantaneous normal speed and normal velocity. Now let's see. So instantaneous speed, simply the magnitude of velocity. Instantaneous speed is magnitude of velocity. You do not need to do anything other than that. Okay, velocity of 24 plus 24 meter per second is speed is 24 meter per second. Velocity of minus 24 plus second 24 meter per second is also speed 24 meter per second. Sign is dropped, magnitude remains. So basically, suppose I say this is positive direction, this is my negative direction. Generally that's how we denote a direction. So this is positive, this is negative. Okay, and if I say that object is moving say 24 in this direction plus 24 or minus 24. Minus 24 means it is moving in the opposite direction. Okay, both cases the average speed should be same, that is 24 meter per second. So in both cases the average speed should be same, 24 meter per second. So in an over a finite interval, average speed is always greater than equals to average velocity. When it comes to average speed, okay, instantaneous velocity, same quantity, magnitude. Okay, instantaneous velocity is equals to instantaneous speed. If you take the magnitude, ignore the sign. Okay, but for average speed they are different. For a finite interval, average speed is always greater than equals to average velocity. Okay, it is always greater than equals to average velocity. Path length can exceed the magnitude of displacement. As I mentioned, the object, this is the displacement, but this is the actual distance traveled. So in that case, the distance traveled is more than displacement. So in that case, average speed will always be bigger quantity than average velocity. Okay, equality holds only when the motion never reverses direction. So the equality or the equal sign for as I mentioned, for motion in a straight line, it can be only going forward and backward. Okay, the curvature motion is not possible. So when the object is moving in a particular direction fixed, okay, without changing its direction, okay, it is moving only in one direction, then average velocity and average speed will be equal. Okay, if the object, suppose I am running forward, then I forgot, okay, I have to bring my mobile phone which is kept at my home. I return back, I take my mobile phone, and then I go towards my friend's place. Suppose, okay, I am going towards my friend's place by walking, okay, which is say 2 kilometers away. I started walking, then I realized my phone is back at home. I went back, I took my phone, and then I went my friend's place. So basically your average velocity is only from your home to your friend's home, but your total average speed will be also considered the backward motion, that you came back, you went forward. So all these motions has to be included in case of average speed. So average speed basically total distance traveled. It can be go forward, come back, again go forward. So everything is included. But average velocity, starting point, ending point, that's it. So average velocity is easier to understand because it's a vector quantity. Starting point, ending point, total distance, what is the distance between these 2 points, and we call it displacement, divided by the time taken, you get the average velocity. Average speed, however, also consider total distance. So it can move forward, backward, etc., etc. How many times it has moved forward, how many times it has moved backward. The total distance is important, not the number of times it go forward or backward. Okay, total distance. So 5 kilometer ahead, then 2 kilometer back, like that. So distance and displacement are different quantities. That's why average speed is always bigger than average velocity. It can be equal only if the object is moving in a particular direction without changing its direction of motion, okay, or the object is static. Okay, that is also a case where the object is not moving, speed is 0, velocity is also 0. Okay, instantaneous speed is always equal to the magnitude of instantaneous velocity. At delta t equals to 0, path cannot bend, displacement of magnitude and path length coincide. Okay, let's move on with the next part, that is acceleration. Now in the part 3 of the session, I am going to discuss about acceleration. Now acceleration means basically the change in velocity, the rate of change of velocity. Now velocity, how fast the velocity is changing. So it can be measured with respect to time or with respect to distance. Interesting, isn't it? So far, whenever we say acceleration, we always say that it's rate of change of velocity, etc., etc. But velocity itself depends on two quantities: the displacement divided by time. Now if I say the velocity itself is changing, now does it mean it is changing with respect to distance or with respect to time? So that is the question that was not me, it was asked in the past. And velocity generally changes during motion. How should we describe this change? Rate of change of velocity with distance or with time? Okay, hold on. It was first thought the change should be described per unit distance. It was not me. It was the first group of physicists who were doing something, measuring velocities, etc. They came up with the idea, okay, position is right. So position, with respect to position, how fast the velocity is changing. But then came Galileo. Galileo did one of his famous experiment where he took some balls and from top of a tower he dropped those balls, and he realized that even though the objects are falling, the rate of change of velocity with time is constant, but rate of change of velocity with distance is not constant. So that gives rise to the gravitational acceleration. We all know that. Also, he proved that all freely falling objects do fall with the same acceleration. So that is another important aspect of the same experiment. Okay, but it is very important and very clear that rate of change of velocity with time is constant, with distance it is not constant. So around 1600s, when Galileo Galilei was still alive, since then actually the rate of change of velocity with respect to time came into picture. So like around 400 years back, right? Super history. So change of velocity with distance is not constant. It decreases with increasing distance or fall. So conclusion, define acceleration as the rate of change of velocity with time. Okay, so it is not there from the beginning of time. Interesting, right? So around 1600s, when Galileo Galilei was doing this experiment, standing on a tower and doing this experiment, and he showed that the acceleration is actually change in velocity divided by the time interval. That gives rise to the acceleration. Okay, acceleration's unit is meter per second square, and I forgot to mention velocity's unit is meter per second. And in the first chapter itself I discussed about the dimensions as well. So what is the dimension of acceleration? Dimension of acceleration is L t to the power minus 2. No mass involved in acceleration or in velocity. This is the dimension of acceleration. Okay, now on a velocity versus time graph, if you plot, okay, average acceleration, slope of the straight line joining the velocity. So what is the graph? So if you plot the graph, suppose this is the velocity time graph. Here it is velocity versus time. Okay, suppose this is the graph. If you again just a second. Okay, if you take a slope same way, okay, so this is delta t, this is delta v, then acceleration is delta v by delta t, with delta t tends to 0. Okay, or acceleration can be written as dv by dt. Same formula, same rules for differentiation. Rules for differentiation is same. Okay, so for example, if x is given, say x is given some value, okay, they are asking what is acceleration. X is given, suppose at plus bt square, something like that is given. Okay, then what is the acceleration? First step is to calculate velocity by doing dx dt. Okay, that will be a plus 2bt, and then acceleration will be dv dt, which will be 2b. Okay, same method, step by step, if you apply, you will get this answer. Okay, so displacement, velocity, acceleration, everything is related, okay, to each other. Now let's move on. Instantaneous acceleration, as I was discussing, that it is limit delta v tends to delta t dv dt as delta t tends to 0. Okay, defined exactly like instantaneous velocity. Acceleration at an instant is equal to slope of the tangent of the vt graph at the instant. Velocity has magnitude and direction, so acceleration may result from change in speed or change in direction, which is very, very interesting, or changes in both. So either it can change the magnitude of v, or if only the direction is changing, there will be an acceleration. One of the major application of this we will see in our next chapter, which will be centripetal acceleration. Okay, we will see in this next chapter centripetal acceleration that actually arises due to change in direction. It occurs because of change in direction, even though the magnitude of velocity or speed itself remains same. Okay, but if the speed is changing, obviously there will be an acceleration, and if velocity is changing only by direction also, there will be an acceleration. So direction is also important while calculating acceleration. Okay, if there is a change in direction, acceleration can change. If there is a change in magnitude, acceleration can change. So acceleration arises because of two things: either magnitude changes or direction changes, or both changes. Both changes, so obviously there will be no doubt about it, but only from direction also there can be an acceleration. Just put this in your head. It is very important point to remember. Now in this chapter we will see that acceleration, variation of acceleration with time, but we restrict to constant acceleration only. Variable acceleration we are not discussing, but there are few graphical questions. We will see how if the acceleration is not constant, what kind of graphs you can get. Okay, we will see that. But for example, here we have an example of positive acceleration constant, positive acceleration. Okay, it's a position time graph. This is position time graph. Acceleration is positive, the graph will be like this. Okay, negative acceleration, the graph is like this. Okay, this is acceleration, decreasing acceleration, x versus t. Okay, zero acceleration, position time graph, it is a straight line. Okay, now so this is a positive acceleration, or acceleration is increasing. Okay, acceleration is positive. Negative acceleration is, graph is like this, and zero acceleration is this. Now in some books the graph is shown like this. This is not a negative acceleration, this is not nothing at all. Okay, so make sure you do not draw that in your exam, because this is a very, very important question. The positive acceleration, negative acceleration, zero acceleration. Okay, for position time graph. Now if the same thing is asked for acceleration time graph, velocity time graph, if the same graph is asked for velocity time graph, okay, positive acceleration, so the graph will be like this. Okay, negative acceleration, graph will be this, and zero acceleration, so this is velocity time graph. These are velocity time graph. So this is also important. These 3 plus 3, 6 graphs, super important. So velocity, acceleration positive, velocity increases, velocity acceleration negative, velocity decreasing, acceleration zero, velocity is constant. Okay, so these are the another 3 graphs that you need to study. Remember basically. Okay, velocity time graphs, 4 cases. Moving in positive direction, positive acceleration. Okay, v is greater than 0 and rising. The graph that I have shown, that This is the velocity time graph. Okay, move in positive direction, negative acceleration. So positive direction, negative acceleration means the graph I have shown. So this is velocity time graph. Now here they have added one more part, moving in negative direction, negative acceleration, v is less than 0 and falling further. Okay, so here the graph will be slightly tricky. The graph will be like this. This is something interesting. Okay, so this is velocity, negative velocity, this is positive velocity. Okay, this is sorry, just a second, one mistake I made. I'll tell you that also, what mistake I made. So this is velocity is already negative, this is positive v, this is negative v, this is time t. Now remember, in any such cases there will be no graph which is in the negative time axis. Time cannot be negative. So I mistakenly drawn the graph in the negative time axis, which is not possible. So that was also a point where a question was asked that which of the following graph is not possible, and actually it was nothing but the negative time graph. So negative time graph is not possible. Okay, moves in plus x till t1 and then returns back with same negative acceleration. So this will be like this. The graph is like this. Okay, so this is some velocity is changing. Velocity is with respect to time. So it was going positive, then coming back 0, like this. That is also possible. So these are different cases, but these two and the 0 case are most important. Now next, area under the velocity time graph, which is very important point. Okay, for any moving object, area under the velocity time graph gives the displacement over that time interval. So this is the basics of our two derivations that we are going to do just very soon. Okay, so if you have a velocity time graph now, for most of the cases we are denoting velocity by this symbol v. Okay, now we need to change this symbol a little bit. We are now going to discuss two symbols. One is u. U is given by u is actually denoted is initial velocity. Then we have normal v, the symbol v, that is final velocity. We also have time t. Okay, and we have a is acceleration. We were using x as displacement. Okay, x as displacement. We can use this as well, but we will use one more symbol s, which also represents displacement. Okay, so s and x, there is no such difference between them, but yes, in our, because we are familiar with certain equations, we will use s. Okay, when it comes to equation of motion. Now another important part, in the exam hall they might give you x equals to v naught plus vt. Okay, so or say not this, sorry, I don't know what is happening. Suppose they give you x equals to v naught t plus half vt square. So do not have any surprise. Basically, initial velocity can also be denoted by a symbol v naught. Okay, and as I mentioned, displacement x and s both are can be usable. Just make sure if the question is there v naught t plus vt square, then you have to use the symbol v naught, not the symbol u. Okay, so these are the few things. Before I continue, I just wanted to tell you, so here we have v versus t. Okay, this is the velocity versus t graph, but at some point of time the value of velocity is u and it is constant. Okay, and after some time t, suppose the object has reached over here, this is the time axis, then this area under the graph actually denotes the displacement. This denotes the displacement of the object. And here, as you can see, this is a rectangle. So this is the side of the rectangle. This side is U, this side is capital T. So area is given by U into T. Very simple. Geometry, we will use geometry, triangle, rectangle, etc. Nothing difficult here. Okay, so a general proof requires calculus, but that constant velocity case shows is the directly object with constant velocity u is equal to t is equal to 0 to t, vt graph, straight line parallel to the time axis, area under it is a rectangle of height h and base t. Okay, so area under that graph is u into t, so that is the displacement in that interval. Okay, how can an area equal to distance? So now you see that the axis, this is the axis. What is the unit of velocity? It is meter per second. What is this axis? This is time second. Now if you multiply these two units, meter per second into second, what is this? This is meter, right? So that means when you are calculating the area, it is turning out to be displacement. So based on which graph you are using, velocity time graph or acceleration time graph or x time graph, so different quantities gives you different values. For example, slope of xt graph gives you instantaneous velocity, slope of vt graph gives you instantaneous acceleration, area under vt graph gives you total displacement, area under at graph gives you average velocity. So that is also super important. Okay. So when you are using AT graph, even though that part is not mentioned anywhere, area under acceleration time graph gives you the instantaneous velocity. That is important. Just remember that. If the graph, suppose this is AT graph, when you calculate the area, this gives you average velocity. Okay, just for your knowledge. Now kinematics equation, we have to do the derivation. So deriving the displacement from VT graph. So here we have a VT graph. Okay, so this axis is V. Okay, we are using V naught. You can use U also, does not matter. Okay, let me change it to U. Okay, let's not use these symbols. Okay, so this is a graph. Okay, this is a graph. So this is the initial velocity U. Okay, after some time t, the object has achieved a final velocity which is given by this v. Okay, so obviously initially it started with the value of u. Initially it started with the value of u, and after some time it reaches a value v. Okay, now we are trying to find what is the displacement. So displacement, as by definition, it is area under the graph. This is the area under the graph. Now this area is not simple to calculate, because either you use the formula for trapezium, or you use this is a rectangle and this is a triangle. Okay, if you can find these two areas, add them, you will get the area under the graph, which is given by, which is the displacement. Now there are two formulas we will derive from this same graph. One is S equals to ut plus half at square. This formula can alternatively written as x equals to v naught t plus half at square. Sorry. This is an alternative form of the same equation. Okay, x equals to v naught t plus half at square. Okay, any one of them will be being asked in the exam. You need to identify. We are using this formula. The second equation we will come to it in a while. But first let us understand this. Okay. So how to do that? So if you see that this distance is what? This distance, this was t is equal to 0. This is t is equal to t. Origin everything is 0. So this is 0 to t. This is u to v. Okay, this is u to v. This height is, what is this height? V minus u. right? This height is v minus u. Okay, now what is acceleration? Acceleration is given by the slope of this graph. So this is the slope. So what is acceleration? Acceleration is given by slope. So that is slope is given by v minus u divided by t, delta y by delta x. So delta y is v minus u, delta x is t. This is acceleration. Okay, we will use it later on, just keep it as aside for now. Okay, we'll use it later on. Now what? Now we are going to calculate the distance, which is given by s, which is area of the triangle plus the area of the rectangle. So basically we need to calculate these two areas and add them. So what is this area? Area of the triangle is half base into height. Half base is time t, half base is time t, and height is v minus u, right? So this is the area of the triangle. And what is the area of the rectangle? Rectangle is height into breadth into length. Say this is length, this is breadth, so it will be ut, right? Now here from this equation we need to find the value of v minus u. So v minus u equals to at. Okay, so just substitute that in this equation. So this, say, equation 1. Okay, this is equation 2. Substituting this equation from 1 to 2, we get this is equal to half t into at, right? V minus u is at plus ut, or ut plus half at square. As simple as that, no complicated mathematics, very simple. Calculate the area, substitute one very basic simplification, and you will get s is equal to ut plus half at square. Now another derivation from here is which is v square equals to u square plus 2as. Okay, this is the second derivation. Again, in this case, as you can see, this equation, there is no t, time is missing, no time is there. Okay, we will start with the first equation again, which is a equals to v minus u by t. Now there is no time involved in this equation, so we will simply find time from this, which will be v minus u by a. Right, so this equation, now again we will be using the same same calculation for s, which is half time t into v minus u plus u into t, right? The same equation, everything is same. Okay, everything is same, only the substitution is different. Only thing that if you substitute here in this equation, if you substitute t, you will get this equation, and if you substitute v minus u, you will get the first equation. So now let us substitute the value of t here, half into v minus u, okay, by a into another v minus u plus u into v minus u by a. Now do the mathematics, you get v minus u whole square plus u into v minus u divided by 2a. So here will be 2. Okay, just LCM is 2a. Here one half was there, so LCM is 2a. Now LCM is 2a means there is no 2 here, so you have to multiply the 2 in the numerator. So just balance it. Now do the cross multiplication. This will come on the other side, and you get 2as equals to, now break this square, you get v square minus 2vu plus u square plus 2vu minus 2u square. Just multiply this. Now 2vu cancels and we get v square plus u square minus 2u square, right? So this minus 2u into u was minus 2u square. Just mathematics, nothing else. No physics here. V square minus u square, right? So just from here we can write v square equals to u square plus 2as. This is the second equation of motion. So both equation can be done using the same equation, same method. Okay, only the substitutions are different. In this equation, if you substitute v minus u, you get s is equal to ut plus half at square. In this equation, if you substitute t in both cases, you get the derivation for v square is equal to u square plus 2as. Okay, this derivation is slightly longer than the other one, obviously, as you can see, but this one is also super important as the previous one. Both derivations are super important for your board exams as well as in your class exam. Right, not board exam, annual exam. Even though it is considered to be a board exam, it is done by your college. So the final exam as well as your all the class exams, midterm, pre-board, etc. Okay, now so this is the normal equation. So first equation that we have done in our derivation, this one. Okay, if you just simplify it a little bit, okay, from here you can write v equals to u plus at. Even though this equation we are not using in anywhere, this is one of the equation of motion. So three equations of motion, v is equal to u plus at. Okay, then s equals to ut plus half at square. So these are the formulas that is given in your textbook. These are the formulas that we generally use in our day-to-day life. So v square is equal to u square plus 2as. Okay, so because many teachers use different notations, no one use v naught t etc. because we do not like to write too much substitutes, right? V naught t, x, y, z, too much confusion. So that's why you use these are the simple forms. Okay, same equation, just common form and the standard given in your textbook. Okay, so here is these are the 5 quantities. Now based on different cases we will use different equations. So this is the most basic equation. If acceleration is known, time is known, initial velocity is known, you want to find the final velocity, use this. Okay, here if you see the velocity is not there, okay, only time and displacement and accelerations are given. Okay, here if you see the time is not given, only initial, final and displacement, acceleration etc. are given. So based on what quantities are given and what quantities you are trying to find, you may need to use different equations. Okay, so if say in a equation in a particular case time is not given, no time is given, which equation you will start with? Obviously you will start with this equation. In this equation time is missing, so you will use this equation only, right? So connect 5 quantities v naught, v, at and x valid for rectilinear motion with constant acceleration. Remember, this is valid for constant acceleration. If the acceleration changes with time, these equations are not very applicable. Okay, derived assuming position at x equals to 0, at t equals to 0 is x equals to 0. So when the initial position x is 0 at time t equals to 0, otherwise you need to add one more position over here. So if the object is starting say at generally x time graph, we always assume that position 0 at time t is equal to 0. Not for velocity time graph. Velocity time graph can be like this, but position time graph is not that. We assume that velocity time position time graph can be only this. Assuming if in some cases if the position time graph is like that, then you have to add that along with. So generally sometimes we add it like this, but that is not gonna come in your neither in your KCET nor in your class exam. So no need to know that, but it is good to have a clarity on this. Okay, rather than memorizing, good to have a clarity. You don't need to memorize it, but you need to have a clarity. In case the position is not 0 at x equals to 0, we need to act that in this equation. Okay. Now starting at x0, this is the value, this is the expression, so each expression changes slightly, so you have to, instead of x, you need to put x minus x naught. Okay, everywhere whenever you are using this, so this equation does not change. Here it will be x minus x naught, here it will be also x minus x naught. So you need to substitute x by x minus x naught. Okay, substitute x equals to x minus x naught, you will get the corresponding equation motion in case the position is not 0 at x equals to 0. Okay, all quantities are positive or negative, sign do matter. For example, if you are considering a positive motion, okay, so generally for all motions we consider our positive x-axis to be positive. Okay, obviously this is the, for time axis, generally time is denoted along this, so this is positive direction, this is positive, this is negative, and this is negative. Okay, generally whenever an object is moving, if it is going up, we consider it is positive. If the object is going down, we consider it negative. For example, gravitational acceleration for an object moving upward, gravitational acceleration is considered negative. Okay, but if the object is going downward, the velocity is negative, acceleration is negative, so we consider them to be positive both. Okay, so it depends on the direction of motion. The object, if you consider that a car moving towards right is positive, then going towards left is considered negative. Okay, so positive negative sign are important, and whenever you are using that equation, you need to make sure you are putting the correct sign to get the correct answer, otherwise your answer will be wrong. Sign convention, so this is called sign convention, and we will see some application as well. Okay, so first, a ball is thrown vertically upward, okay, at 20 meter per second from the top of a building. The launch point is 25 meter above the ground. Okay, how high the ball rise? When does it hit the ground? Take g is equal to 10 meter per second. In most cases, we will use the value of gravity as g is equal to 10 meter per second square. Okay, that is most reasonable assumption. Okay, that saves some time and complicated calculation. So ball is thrown vertically upward at 20 meter per second from the top of a building. So here we have a top of a building. Okay, this is a building, some windows are there, and at the top of this building you are standing. Okay, and you have thrown a ball, okay, with a speed of 20 meter per second. Suppose the ball rose to a height of h, and then it falls down to the ground. So first of all, first thing is you need to calculate what is this height and what is the total time. Suppose t1 is the time it takes to reach the top, and t2 time it takes to reach the bottom from this top. Okay, we have to find t1 plus t2. We need to find time t1 plus t2. So first step is to find this h. Okay, so when you throw a ball, what happens? When you throw a ball, if you see that the ball, this is a ball, suppose. Okay, this is not a ball, this is a pen, but for now assume this is the ball, and when I am throwing it upward, what happening is that for a moment it is stopping. For a moment it is stopping, then it starts to fall. Okay, why it is happening? Because when I am throwing it upward, the gravitational acceleration is trying to pull it down. Okay, so the velocity is trying to take the object in the upward direction, but the gravitational acceleration is trying to take it in the downward direction. Okay, and that's why what happens is that when I am throwing the object in the upward direction, okay, it is stopping at the top. Okay, so basically that's the only information we need to know, that at top okay, the velocity is equals to 0. So at the top position, velocity is equals to 0, and using this we will be solving the question. First, obviously the height. So what equation we'll be using? We'll be using v square equals to u square plus 2as. This equation we'll be using because our target is to find this height. Time is not given in this particular case, so we will be not be using that. Okay, so now so v square is 0, final velocity is 0, u square is 20 meter per second. Okay, so 20 square plus 2 into gravitational acceleration is minus g. Okay, because the object is moving upward. Okay, the gravitational acceleration is downward, so g must be negative. G must be negative. Okay, into s. S is the height that it is reaching, that we are trying to find out, right? Or it will be 400, 20 square is 400 minus 2 into 10 h. G's value is 10, right? So we can get 20 h equals to 400 or h equals to 20 meter. So the ball will rise to a height of 20 meter. This is the maximum height that is achieved by the ball. Now what? Now we need to find that, so we have find that the ball is rising to the 20 meter height. Okay, and now we have to find the total time. So this is say t1, t2, t1 plus t2. Now there are two ways to do it. First you calculate t1, 1. Next you calculate t2, 2, and then add them. That is one way to do it. Second way is that it is given that the height of this building is capital H, which is 25 meter. So if you read the question carefully, the height of the building is given 25 meter, right? The launch point is 25 meter above the ground. That is basically the height of the ground. So from where you are throwing it, okay, from where you are throwing it, that is 25 meter above the ground. So the displacement of the ball, is actually only 25 meter. So that information we can use, and we can calculate the time directly without requiring to calculate the top and bottom motions individually. We can directly calculate the time. Okay, obviously it will be giving you so displacement is known. Okay, final velocity is not required. Initial velocity is given. Okay, initial velocity is given. So how to calculate? So h equals to ut plus half at square. Okay, so h is 25, u is 20, time we are trying to figure out, plus half minus 10 into t square. Okay, so this will be a quadratic equation. I hope you have solved quadratic equation. If not, I will help you, don't worry. Okay, so this is a quadratic equation. We need to solve it. Let's take it on the other side. 5t square minus 20t plus 25 equals to 0. This is a quadratic equation. Now this is obviously, I think it is factorized. You can factor it, right? 125 means 5 into 5 into 5, 15 into 5, no, 15 into 5 is not possible, 10 into 10 is 100. No, you have to use the quadratic root formula. Quadratic root formula is very simple. It says time t equals to b. Okay, so quadratic equation is this. Suppose we have an equation ax plus ax square plus bx plus c equals to 0. So this is the quadratic equation. So when the order of the x is 2, that is called quadratic equation. Okay, if the order is 1, then it is a linear equation. This gives you a straight line. okay, but if the order is not 1, okay, then it gives a curved line, and that is actually called a quadratic equation. So one of our ancient mathematician from India, Sridharacharya, he did some calculation, and in his book he mentioned how to find the roots of this equation. Root means the values for which it will be valid. So if you find the values of x where this right hand side is 0, that is called roots of the equation. It is not valid for every equation, every value of x. There will be only 2 values of x for which this equation is valid, okay, and those 2 values of x are called roots of this equation, and that can be written as x equals to minus b. Here it was plus, so minus b plus or minus square root of b square minus 4ac divided by 2a. Okay, this is called the root of this equation. These are called the root. So here is a plus value, here is a minus value. So if you are using the plus value, you will get one root. If you are using the minus value, you will get the second root. So these are the roots of this equation. Okay, and here also you have to use this. Now here, instead of minus b plus b, minus 20 is given. So t equals to 20 plus or minus square root of b square means 20 square, minus 4ac, minus 4 into a is 25, sorry, a is 5, c is 25, okay, divided by 2a, 2 into 5, okay. Now let's see what value we will get, okay. So it will be 20 plus or minus 400 no, there's some, maybe some mistake. I may have done some mistake. Let me check once. Yes, one mistake I made because I assumed that the positive side is this one and we kept this as positive. So the displacement in the downward side must be negative. So that is one thing that you need to be careful about this method. Okay, because the object is falling down, for downward displacement this must be negative. Okay, otherwise it will get an imaginary value. So be careful, you don't make that mistake when you are doing it. So minus 25, so here it will be minus 25, so this will be plus. Okay, so let's see, 400 plus 500 divided by 10. Okay, so it will be 20 plus or minus square root of 900 divided by 10. Now square root of 900 is 30. Square root of 900 is 30. So plus or minus 30 by 10. Now if you see that, if you are taking the negative value, time is coming out to be negative. Time cannot be negative. That is one very important thing. You need to always remember, time is always greater than equals to 0. So when the universe started at the Big Bang, time was 0, and since then time is always increasing. We do not know what is beyond that. So negative time does not exist in our physics class. Okay, so negative time is not there. So time is always positive, and that's why it will be only the positive value we will take. So t equals to 20 plus 30 by 10, that is 5 seconds. So the ball will take 5 seconds to reach from top to bottom. Now little complicated, let me clear it once more. Okay, first of all, this is the Sridharacharya equation, or called quadratic root equation, where if the equation can be written is like that, you can find the roots of this equation. Root means what? If you take these values of x and substitute in this equation, left hand side, right hand side, both sides will be 0. Okay, so that's why it is called roots of this equation. So derivation of this can be done in geometric way, but obviously not in this class mathematically. Some of you may know it, some of you may be using it in the class 10th also, but you will learn it in your class 12th mathematics, 11th or 12th mathematics, it is there. Okay. Now this is called the roots of the quadratic equation. Now one more another part is that whenever you are considering a particular direction to be positive, everything else in the opposite direction will be negative. Okay, so we consider that the 20 meter per second in the top side is positive, it is going upward. So downward side the displacement, okay, the displacement is negative, the gravitational acceleration is also negative. So these are the two things that you need to remember, that whenever you are considering a particular direction as positive, everything in the opposite side will be negative. Okay, so this is the way to solve a question where you are throwing a ball from the top of the building. Okay, ball will reach some height and then it will fall again. So if you are trying to solve the individual times T1 and T2, that is also doable, but that takes longer method, longer time. You need to learn the fastest method, because if the same question is asked in your KCET exam, you will not get the time to calculate T1 and T2 and then add them. That will be very long time. But instead, if you are using this method, okay, as soon as you put this in the formula, as you can see, the values are easily calculatable. Okay, only thing, another important point, time cannot be negative. If you remember that, your answer will be done. Okay, just try to solve it once more on your own to figure the problem out once more. Okay, now let us understand which is called free fall. Okay, free fall. What is free fall? Free fall means an object released near Earth's surface accelerates downward under gravity. Free fall is basically motion under gravity, okay, when air resistance is neglected. If an object is falling under gravity without any other external forces, then it is called free fall. Free fall means only gravitational force is acting on the object. Air resistance, you are ignoring it, or you are creating a vacuum, then it is called free fall. If fall height is very less than Earth's radius, g is constant. Okay, so if you are considering say 10 kilometer, 20 kilometer, 30 kilometer, radius of the Earth is 6400. Radius of the Earth is 6400 kilometers. Okay, so if you are considering a distance 100 kilometer also, which is very small compared to size of the Earth, so we can assume that gravitational acceleration is almost constant. The variation is ignorable. Okay, so in that case, uniform acceleration happens. So the object which is falling falls with an uniform acceleration, constant acceleration. Uniform acceleration means constant acceleration. Choose upward as positive. Motion is along negative y-axis, so A is minus g. So always when the object is falling under the gravity, you always take the gravitational acceleration to be minus 9.8 meter per second square. Released from the rest at y is equal to 0, okay, v is equal to 0, equations become, so if you are using equation of motion, okay, the velocity of the object after some time is given by minus 9.8 t. Okay, so if you are dropping something, what will be its final velocity? Just take 9.8, multiply with the time, you get the velocity. Initially it was 0. Right? If you are trying to find how much distance it had traveled, minus 4.9 t square. Okay, and if you are trying to find the final velocity square with respect to this, v square is equal to minus 19.6 y. Basically you just take the square of this, substitute it, you will get this value. Okay, actually any two of the equations are unique. Minimum two equations are required to interrelate between the values. Okay, third equation can be calculated from the first two. Okay, anyway, so this gives the velocity, displacement, etc. Okay, and with respect to time. Now let's see Galileo's law of odd numbers. This is something very interesting. Okay, distances traversed in equal time intervals by a body falling from rest, okay, stand to one is to another as the odd numbers 1 is to 3 is to 5 is to 7. Okay, so basically what is the question? It is says that suppose we have a height. Okay, we drop a ball, okay, at t is equal to 0. Okay, after, this is a very long building, after 1 second, suppose it traveled a height h1. Okay, this is t1. Now after time t2, it traveled a distance h2. After a distance t3, it traveled say h3. It says that this is, if the interval is equal, if the 1 2 3 4, it can be any other constant also, but if the intervals are equal, okay, the ratio of these heights will be h1 is to h2 is to h3 will be 1 is to 3 is to 5 is to 7 is to 9, like that. Okay, the ratio is constant. Okay, if you consider the equal interval of time, here they have taken tau, 2 tau, 3 tau, 4 tau, 5 tau, 6 tau. Okay, the ratio, the distance of interval is important, not the total distance traveled. Okay, the interval, the between these two interval, what is the distance traveled? Okay, so initially it started with initially when time t is equal to 0, it was 0. So between 0 to 1, this is the distance traveled. Between 1 to 2, this is the distance traveled. Between 2 to 3, this is the distance traveled. So if you take all these distances, it will all be a ratio of odd numbers. It will all be a ratio of odd numbers. That is what discovered by Galileo in some centuries back. Okay, he was performing this experiment in the Minor of Pisa, and he dropped the balls and measured the times and etc. Okay, so you can search for Minor of Pisa, you will get a beautiful picture. Okay, now let us discuss another constant, which is stopping distance of vehicles. So if you suppose a car is going on a road, suddenly it sees a person trying to cross the road, somehow stuck on the road, and a kid, suppose his ball fell on the road and he is trying to retrieve the ball. Okay, what the driver will do? Driver will start applying brakes so that it stops before the child, right? It should not hit the child by mistake, right? So the distance the car will travel before it comes to a rest, that is called a stopping distance. If the distance is not enough, if the driver applies the brake much later, then there will be a chance of collision. Fatal accident might happen, and that happens because of this. Okay, so that's why whenever you see a long truck moving on a road, it is mentioned that long vehicle keep distance. Okay, because if you lose control and if you ram your car or vehicle into that long vehicle, okay, it might cause a much major accident on the road. That's why it says that long vehicle keep distance. You keep the distance which is minimum your stopping distance. Okay, in case I have to stop, you also need to stop, so that there is no accident can happen. Okay, so that's why always whenever you drive, or in future whenever you drive a car or vehicle or anything, whatever you are driving, always try to keep a safe distance between you and forward person. Do not drive in his back, there is a high chance of accidents. Okay, but if you are keeping on a safe distance, okay, if the person in front of you applies brakes, you can also apply brakes and stop. Okay, so stopping distance is basically the distance a vehicle travels before stopping after brakes are applied. Okay, it can be very small. For a good quality car, very expensive car, the distance is very small. It can come down from 120 to 0 in say 100 meters. Okay, which is very, very good. Okay, depends on the initial velocity and the braking deceleration. Now negative acceleration is called deceleration. Okay, so suppose acceleration means speed is increasing, deceleration means speed is decreasing. Okay, that's why negative acceleration is called deceleration. So if I say that I am increasing my speed when I am starting my accelerator, okay, pressing my accelerator, okay, and if I apply brakes, then basically I am applying deceleration. Okay, accelerator gives you acceleration, and decelerator, say brakes, give you deceleration. Okay, so accelerator gives you acceleration, brakes gives you deceleration. Okay, brakes basically decreases the velocity. So decreases velocity means acceleration in the opposite direction, which is called deceleration. Okay, so derivation, v square is equal to v naught square plus 2vx, or say v square equals to u square minus 2a, say d stop. Okay, so we are trying to find this d stop, so that will be 2a d stop equals to, now at the final velocity is 0, final velocity is 0, right? So when the object applied brake, when it is coming to stop, final velocity is 0, so 2a ds equals to u square. Okay, final velocity is 0. Okay, that means the distance of stopping will be u square by 2a. This is the distance to stop. This is the distance to stop. Now sometimes we add a negative sign to avoid the negative sign with the deceleration, but if you add a negative sign of this here, you will be basically need to take the magnitude of deceleration. So if you apply a brake, okay, based on the deceleration of the brake, you require minimum this distance to stop. Okay, you require minimum this distance to stop. Now if you want to stop at a very high speed, so you need to have a very high deceleration. So brakes must be very, very efficient, very good, so that you can stop at moments of notice. Okay, now let's wrapping up our chapter. So motion and position. Okay, so an object is in motion if its position changes with time. Position is specified with respect to a conveniently chosen origin. Right of origin, positive side. Okay, left side is negative. So as I mentioned, if you go in this side, this is positive. Okay, and if you go in this side, this is negative. Okay, velocity, there are average velocity, instantaneous velocity, slope of the tangent of the graph gives that instant velocity. Okay, average speed is always greater than equals to average velocity over an interval. Equality refers to either the object has not changed any direction, or both objects are at static. Okay, acceleration A is equal to average velocity is change in velocity by time. Okay, and instantaneous velocity is dv by dt, so here it is dvx by dt. So if you write it in differential form, it will be dx by dt. Okay, slope of the vt graph at this instant, area under the vt graph is basically gives you displacement. Okay, area under the velocity time graph gives you displacement, area under acceleration time graph gives you average velocity. Remember that. Okay, uniform accelerations, of different graph shapes also we have discussed. Now let's move on with the equation of motion. V is equal to v naught plus at. This is the standard formulas form book. So at the end, let's keep that form only, but when we solve numerical questions, we will use our standard values that we use, right? But when in the exam, these forms are important, because in the exam, in the question paper, they will ask you x equals to v naught t plus half at square. Derive v square is equal to v naught square plus 2ax. So be aware of these equations as well. Okay, each equations omits exactly one of them. So if you see here, okay, here no x is involved. Okay, here no v is involved, here no t is involved. So each equation actually omits one quantity, v naught, a, t. There are, and x, there are 5 quantities, and you require 3 of them. Okay, so validity definitions are a, v and a are exact and always correct. Okay, kinematic equation hold only when magnitude and direction of are constant. Okay. these are called three equations of motion. These are called three equations of motion. This is 1, this is 2, this is 3. Okay, there are three equations of motion. There is one more equation of motion, not exactly equation of motion I will say, but time interval between two intervals, distance travel between two intervals when it is accelerating. We will do that in maybe in the next chapter, not here, not today. Okay, now so something that students often miss, so let us discuss some of the points like that. Origin and positive direction of the axis are your choice. Specify it before assigning signs to displacement, velocity or acceleration. So even though we say that right side is positive, left side is negative, okay, top side is positive, bottom side is negative, but that is up to you. Okay, if you see that everything is in the bottom side or everything is on the left hand side, you take left hand side positive, solve it, it is fine. Okay, but if you are using left hand side negative, right hand side positive, that sign convention is completely up to you. You can change the sign convention. Usually textbook wise, teaching wise, whenever we consider positive and negative, we say right side positive, left side negative, all the objects moving up is positive, all the objects moving down is negative. Now if suppose I drop a ball from some height, ball is moving downward, there is no upward motion at all in this case, right? In this case the ball is only moving downward, so its velocity is increasing in the downward direction, its time is also in the downward direction, displacement is also in the downward direction. So if you ask me to solve the problem, I will take the downward direction as positive and solve it. I will not use unnecessary negative in each and every quantity, cancel them, no need. So the direction is completely up to you. What direction you choose, be it positive, negative, that is completely upon you. But yes, if there is a mix of directions, upward, downward, right, left, then you have to stick one direction as positive, another direction has to be negative. So that is super important. But as I mentioned, if all the motion is happening in a particular direction, then we take that direction as positive and we do not apply the general law right, left, up, down. Okay, so that is one very important point to remember when solving any numerical questions. Right, now let's move on. The sign of alone does not say the speed rises or falls. A falling particle with negative a still speeds up. So as I mentioned, the sign of acceleration does not always say that whether the object is increasing or object speed is increasing or decreasing. So here basically if the object is falling down, then we will say that its speed is increasing even if sign of the acceleration is negative. Okay, speeding up is along v, slowing down a is positive to v. Okay, true regardless origin axis choice, so it can be anything. Okay, so a and v are opposite, then it is slowing down. Okay, speeding up, a and v are in the same direction. If a and v are in the opposite direction, then object slows down. If a and v are in the same direction, object speed increases. So that is more common point. Okay, zero velocity is not equals to zero acceleration. A ball at its topmost point has v is equal to 0 but g is equal to minus g. So this is another very important point. If the velocity of the object is 0, it does not necessarily its acceleration will also be 0. Okay, you will see throughout your entire P1 there are many cases where acceleration is not 0 but velocity is 0. One such example that we have studied here. So when you throw up the ball, okay, when it moves to the topmost position, at this topmost position there is no velocity, ball is not moving for a moment, for a second, okay, but then it starts falls down. Now because the gravitational acceleration is acting downward, so acceleration is acting downward but the velocity of the ball at this moment is 0. So velocity is 0, gravitational acceleration is not 0. So if you throw the ball up, as soon as it stops, if you catch it, basically you are catching it when the velocity of the ball is 0 but acceleration is not. So acceleration can maybe acting on the object even if the velocity is 0. Super important. Okay, and if velocity is 0, acceleration is 0, then object will not move at all. Okay, all quantities in the kinetic equations are algebraic. Okay, substitute with the proper signs if they work every 1D constant case. So basically you just need to take the value and put it in the equation, that will be satisfied. Okay, they are algebraic, there is no complex geometry, complex number are involved here. Okay, equations, so some equations, if you are following from NCERT textbook, do note these points as well. Okay, now next, selected exercise. Which of these can be treated as a point object? So let's see. A railway carriage between stations, a monkey on a cyclist on a circular track, a spinning cricket ball turning sharply on a bouncing wicket, a tumbling breaker of a table. So here if you say that a railway carriage between stations, basically the stations, distance between two stations is very long, so definitely a railway carriage can be considered to be a point object. A monkey on a cyclist on a circular track, so if the track is long enough, you can consider that monkey is also a point object. A spinning cricket ball turning sharply on a bouncing wicket. Now spinning cricket ball, the length of the pitch is large enough, the size of the ball is very small compared to the size of the wicket, right? If you have seen cricket, right? So the size of the ball is smaller compared to the distance between the bowler bowling and the batsman batting. That means you can still consider it to be a point object. A tumbling beaker of a table. So beaker falling off the table, okay, or that beaker on the table, but it's tumbling, it's fall down on the beaker. Obviously the displacement is very small, so you cannot consider to be a point object. So except this one, all the objects are point objects, can be considered point object. Okay, from XT graph of a children A and B returning from school, who lives closer, leave that. Let's solve some numerical question. Okay, a car at 126 km/h stops within 200 meter. Find the uniform retardation and the time taken to stop. So let's see. So this is a very interesting question. Okay, this is exercise. All the exercises are from your textbook only. Okay, exercise 2.5. The car, initial velocity of the car was 126 km/h. Okay, now how to now the stopping distance here is given by how much? 200 meter. Okay, they are asking you what is the acceleration or retardation basically, okay, and what is the time of stop. Okay, these two things you need to find. Now first thing, if you see that the distance is given in meters, the speed is given in km/h. So first step is to convert this km/h into meter per second. How to do that? 126. So whenever you see that km/h is given, always multiply 5 by 18. This will give you in meter per second. So whenever you see km/h is given, always multiply 5 by 18 to convert it into meter per second. That is the shortcut way to convert. Otherwise you can multiply 1000, divide by 3600 and do it, but that is much more longer method for exam specific situations when the time is short. Okay, you need to do it faster. This is the shortcut that you need to remember. So here it will be 9 to the 18, here it will be 63, 7 9s are 63 and 7 5s are 35. So 35 meter per second was the initial speed. When the car stops, its final speed is 0. Okay, so that means first of all v square equals to u square minus 2a s. Okay, assuming that obviously it is retardation. So 0 equals to 35 whole square minus 2 into a into 200. Okay, s is given here 200 meters. So now it will be a equals to 35 into 35 divided by 2 into 200. Obviously you need to calculate it, simplify it using some calculator. You need to calculate it, right? 5 7s are 35, 5 4s are 20, 5 7s are 35, 5 8s are 40, so it will be 49 by 16. 49 by 16, it will be approximately, obviously, 3 meter per second square. Okay, slightly more than 3. 16s are 48. Here it is 49, which is very close to 3. So it will be 3 meter per second square, very closely. If it is a competitive exam, they will give you 3 meter per second square, of course. Okay, now what about the time? Time, to calculate time, we will be using V equals to U plus AT. Okay, obviously A is negative. 0 equals to 35 minus 3t, or t is equal to 35 by 3, okay, which will be approximately 11.67 seconds. Okay, 11.67 seconds. Okay, now let's see one more problem. A ball has thrown up at 29.4 meter per second square. Direction of the of A during ascent, V at the top, height, risen, and the time to return. Okay, so there are few problems. First of all, the ball is thrown up. This is 2.6. Okay, so that is, a ball is thrown up at 29.4 meter per second. Okay, so initially you threw up the ball at 29.4 meter per second square. Okay, now what? Direction of A during ascent. So direction of A during ascent means when the object is going up. Ascent means going up. Okay, going up is called ascent. Okay, and going down is called descent. Okay, so ascent means when the object is going up, velocity is going up. Okay, the acceleration is going down. So the direction is negative. Okay, next what? V and A at the top. So at the top, when the object reaches at the top, velocity becomes 0, acceleration is minus 9.8 meter per second square. Okay, so ascent means going up. So when the object is going up, okay, so the direction is down. Okay, so during the ascent, acceleration is minus g, that is minus 9.8. Okay, so that means at the top, velocity is 0, acceleration is minus 9.8. Okay, height, reason, and time to return. So same problem, height, reason. So what is the height, reason? I will only solve the height, reason, time to return. I will solve the equation. I will give you the equation, but you have to solve it on your own for a practice. Okay, so height, reason. What is the formula for height, reason? V square equals to U square minus 2GS. Directly I am using this. Okay, directly I am using the formula. Don't worry, you can use that as well. So V is equal to 0, U is 29.4 whole square minus 2 into 9.8 into H. Okay, so you need to calculate H. A is equal to 29.4 into 29.4 divided by 2 into 9.8. You take your small calculator and calculate it. You will get the value of height, and that will be in meters. Okay, next is, as I mentioned, so the top height is given. Okay, okay, so basically they are not they have not mentioned that with what time it is being basically thrown up. So it is throwing up from the ground, I am assuming. So basically you can find the time taken to rise to the height, say t1, and the falling down. So if time taken to rise up is t1, time to fall is also t1. So total time is 2t1. So this one you can use. Okay, this formula you can use to calculate. This one is much easier. This one is not required to solve. So how to solve that? So V is equal to U minus GT1. So when the object is being thrown up, at the top position V is 0, G is minus 9.8, okay, and the time taken, say T1. Initially the velocity is 29.4, okay. So from here you can actually find that T1 equals to U by G, okay, which will be 29.4 by 9.8, which will be 3 seconds. So total time of flight is, if it takes time 3 seconds to go up, it will take the same time to come down as well, okay, if it is only fall. If it is like a throwing from a top of a building, then you need to use that complicated calculation. So this will be 2 into 3, this 6 seconds, okay. So this is the few exercise problems you should solve. Some hints I have given in the question itself, so do check them out and solve as quickly as possible, okay. And please let me know in the comment section how many you are able to solve, okay. Now let us summarize the chapter. Define instantaneous velocity, speed and acceleration as limits. So these are the things that we have learned. Read x versus t and v versus t graphs. Slopes give VA, area under VT gives displacement. Derive and apply the 3 kinematic equations for constant acceleration. Solve free fall problems with consistent sign convention. Explain Galileo's odd number law, okay. Stopping distance and reaction time, okay. Reaction time is the time to which you can react to avoid accident. That time gap is called reaction time, okay. Stopping distance, reaction time. Thank you for watching this. Next chapter will be motion in a plane, okay, which is chapter number 4. And obviously try to solve the questions as much as possible and mention that in the comment section below. And one very earnest request to all of you, if you have not yet subscribed to our channel, don't forget to subscribe to our channel. All PU1 chapters will be completed in our channel, that is my guarantee. I will do all the PU1 chapters in one shot, so that you don't need to go anywhere else, or you don't need to look for parts, part 1, part 2, part 3. Oh, I am confused. We will be giving you all chapters one shot and with all discussions. In future we will also add few KCET questions as well, and that will be it one shot for all important chapters at one go. You don't need to think too much about it. Right now, this is the time for me to end this session. I'll be back with the next chapter. Till then, bye.